This lesson is part 2 of what we started last time over lines in the coordinate plane. We're specifically talking about parallel and perpendicular lines. We've made parallel and perpendicular lines with our Comtractor this unit, and we did a lot with parallel lines in the first 2 lessons with like AIAs and SSIs. So that's kind of why it fits here. Let's jump right into it. Hopefully you know and remember, and again, side note guys, this is all review from Algebra 1, every single bit of it. So hopefully at least something's familiar to you. But parallel lines and perpendicular, hopefully you remember a little bit about them. The symbol for parallel is that, it's like 2 slanted lines. So if I just made a rough sketch, obviously it's not perfect, but maybe something like that. And parallel lines, again, just giving a rough definition, they're lines that don't intersect. We know that. They never cross. What's review about this, because lines, parallel lines is a lot of geometry, but the algebra part of this is talking about the slopes of parallel lines. If you guys remember, parallel lines have the same slope. And it makes sense if you look at the picture. Like if you counted the slope of this line, it's like up 2 over 1. This one would also be up 2 over 1. They have the exact same slope. Perpendicular, the symbol is an upside down capital T. So if you ever see that, that means perpendicular. We'll see that this year. And if I made a sketch, I could just do something like this. Those look like perpendicular lines. And perpendicular lines, the definition, they're lines, so they do intersect this time, unlike parallel. They intersect at a right angle. I don't know why I cannot write smaller, but I just can't. They meet at a 90-degree angle. So on the picture, they'll usually, not in the algebra stuff, but geometry, we'll put like the little square there to show 90. Okay, here's the big thing. Again, this is what we're really after today, remembering about the slopes. So parallel have the exact same slope. Perpendicular, they don't have the same slope. Their slopes are completely different, and more specifically, they're called opposite reciprocal slopes. Okay, let's break that down. Opposite means like one's positive, one's negative. They're opposite signs. Reciprocal means that they're flipped. So let me give you an example here. Say that one of the lines has a slope of negative 3 over 2. The line perpendicular to that would have the opposite sign. So since this one's negative, this one would be positive. And it would flip this guy. So it would make it 2 over 3. That's the reciprocal. So negative 3 over 2 and positive 2 over 3, those are perpendicular slopes, opposite reciprocals. Okay, that's the big thing to know. A couple special notes here. All horizontal lines are parallel. And I feel like we would kind of be able to piece that together, okay? So 2 horizontal lines, obviously those are never going to cross. Those are parallel. Same thing, 2 vertical lines are always parallel. Like those guys, they're never going to cross. And then kind of thinking along the same lines, a horizontal, along the same lines, a horizontal line and a vertical line. I need to get a life, I know. There's a typo. A horizontal line and a vertical line are always perpendicular. Okay. So slopes is the big thing that I'm thinking about here. If they give me an example, and again, this is Algebra 1 review. You've done stuff like this before. Not to say I think you remember it necessarily, but you've done it before. They give me 2 equations of different lines, and they tell me, are the lines parallel, perpendicular, or neither? You don't need a picture to judge by appearance. All you have to analyze is the slopes. Okay, if you're wanting to identify a slope, you want to be in mx plus b. You want y to be by itself because then whatever's sitting in front of x, that's the slope. So if you look at example 1, both of those are in mx plus b. So that makes it really easy. The slope of the first one is 1/2. The slope of the second one is 2. Okay, so I have 1/2 and 2. Those are my two slopes that I'm looking at. Obviously, these are not parallel because 1/2 and 2, not the same number. These are also not perpendicular. They are reciprocals, like they're just flipped of one or the other. So like it's 1/2 and then 2/1. But they're not opposites. They're both positive. So these lines are neither parallel or perpendicular. And my reason would be, I would say, because you could either say like they're both positive. I'm going to be really mathy and I'm going to say they're reciprocals but not opposites. Really close to being perpendicular, but not quite. This is such a common question. I guarantee you see this on an exam. They'll make it reciprocals, but not opposites, just to see if you're paying attention. All right, on the next one. So I'm going to go ahead and just do this one for you. On the second line, here's the slope. It's -3/5. So that's in mx plus b. That's easy to tell the slope. But the first line is in standard form. So the first thing I want to do, because I cannot look at standard form, I can't say, oh, the slope's 5. What's in front of x? That only works when you're in mx plus b. So I need to get y by itself. Okay, so I'd move the 5x over and then divide by -3. And it would be y equals, it's negative over negative, so it would be positive 5/3 x minus 3. Now I can see that the slope is 5/3. So my slopes are -3/5 and positive 5/3. These are opposite reciprocals. So these slopes would be perpendicular, and I would just say because they're opposite reciprocals. Okay. On the back. So these are fun questions every time. Basically, you're kind of doing what we did last time, just one more extra thing added in. And it's talking about parallel or perpendicular. But your goal is to write the equation of the line. We did these last time. So my goal is to write mx plus b. I need m, I need b to be able to write my answer. So what do I know about the line that I need to write an equation for? Well, I know that it's parallel to this line, and I know that it needs to go through that point. Okay, visuals always help. So if you're like totally stuck, you could just draw a picture. That might help you make some sense of this. So I want my line to go through -2, 6. So it needs to go through that point right there, and it needs to be parallel to this line. So my line needs to be like something like this. Okay, I just need to write an equation for that line. I need two things. I need m and I need b. You always, always, always find the slope first, which is your m. It's pretty simple if this line that you want to be parallel or perpendicular to is already in mx plus b. Okay, the slope of this line is 3. I want my line to be parallel, so I just want to use the same slope as that line. So guys, I'm going to go ahead and start my answer already. I know that I want my slope to be the same. So I'm going to use 3. If it said perpendicular, I would do -1/3. But since it's parallel, use the same. I just need the b value now, so that's my second step. Find the y-intercept, which is b. People make the mistake, they use the same b value as this one, but if I did that, then it'd just be the exact same line. I'd be starting at -1 and I'd go up 3/3. I know that my line, and if I do like a rough sketch, it needs to look something like this. So its b value is way bigger than -1. It's all the way up here somewhere on the y-axis. Worst case scenario, you could graph this thing and just count up 3 over 1, up 3 over 1 until you hit the y-axis, but I'll show you a different way. You can use the point and your slope and mx plus b to figure it out like we did last time. So on your point here, that's an x and a y value. So you're going to plug those into mx plus b. Y is 6, the x is -2. I don't know the b, so I'm going to keep plus b, but I do know the slope. I'm using the same slope as the first line, so the slope is 3. So then all I have to do is do 3 times -2, and then solve it for b. And that makes sense. A b value of 12, like all the way up here. So that is what I put to complete my answer. All right, let's do one more here for you. So this one's a little bit harder, doesn't get worse than this. Same goal though. I want to write mx plus b. I need m, I need b. So this time I want to be perpendicular to this line, and I want to go through this point. Okay, first step, you got to find the slope. Now, here's the problem with this one. This one isn't as easy because this line was given to me in standard form. So I need to solve it for y, so that way I'm looking at mx plus b. And I feel like I've done this many times now in the past couple of days, so I'm kind of going fast through this part. But that would be 2x plus 17 over -2. That's a decimal. I'm just going to leave it because honestly, I don't care about the y-intercept of this line. My y-intercept is different. I'm just looking at the slope here. So the line I want to be perpendicular to has a slope of 2. I want to use the opposite reciprocal of that. So the opposite reciprocal of that would be -1/2. That's what I want to use as my slope. Perpendicular, opposite reciprocal. Don't use the same in this case. Okay, I have the m, I just need the b, so that's my second step. And to do that, I'm going to do the same thing I did last time. So here's the x and the y. I need to use those. And I'm going to use my mx plus b form to do this. You could also use point slope if you're into point slope. Ew, don't tell people if you're into point slope. It just makes you sound weird. But I know the y value is -1 of the point. My m that I'm using is -1/2, and the x value is 8. I don't know b yet, so put plus b. -1/2 times 8 is -4. And then I would just solve for b by adding 4. So b would equal 3. So I would just write that at the end of my equation, and there's my answer. All right, that wraps up Unit 3. We are officially done.